All right, well, thank you everyone for joining me today. So my name is Sean Weiss. I'm the SE manager for Western Canada. Maybe just real quick, somebody in the chat window, just give me a wave or maybe a bit of a note there that, that you can hear me. All right, I'm going to take that as affirmative. Let's keep going. All right, so today we're going to talk a little bit about building the next generation security operations center. We're really going to hone in on a couple of buzzwords, a couple of strategic terms that really define, I think, today's modern SOC. Right, so we're going to talk about things such as, we'll talk about machine learning a little bit. We'll talk about automation. We'll talk about integration. We'll talk about why these are so important to today's SOC. Now, before we do that, let's have a little bit of fun. Anybody that's seen me present before, you'll know I'm a bit of a history buff, and I like to kind of go back in time a bit and sort of do a lessons learned, or at least just have some Jeopardy-like fun here with how cybersecurity and those sort of topics have come a long way from days of old. So what I'm looking for right here on this slide. And I'm going to send you out a prize. So use the chat window to answer. Use your chat to send the answer. But basically, what I'm looking for here is give me an idea here of the first hack of modern communications. Right. So what I'm looking for here is maybe the date, maybe the country. When, or maybe the technology that was involved in the first hack of modern communications. Someone said 1980. I'm looking for about something that was almost 200 years before that. Marconi. All right, so you've seen me talk before, and I do talk about the Marconi hack, but that's not the one I'm looking for. This is even before Marconi. Marconi did the wireless hack. So I'll give you a bit of a hint. 1820, very close. That was Noman Zahir. So Noman, I'm going to give you credit for that one. This is actually 1838. This was the telegraph that had been hacked. Now, the telegraph was invented in France. It had been invented in the 1790s. And about 30 years after its invention, a couple of crooked bankers named Francois and Joseph Blanc, which is my mom's maiden name. So I could be related to these two characters. I don't know. In fact, they came from the same part of France that my mom's grandfather came from. So I could be related to these guys. But anyways, that's another story for another day. These two guys basically were manipulating the prices of commodities in a commodity trading endeavor that would sort of start off in Paris, and that would sort of define the prices of various commodities. But using the telegraph, they would actually send coded messages to other markets where they knew they could manipulate the price by buying a commodity that was perhaps going to go up in value the next day. And so the telegraph, almost from its inception, was being used for ill-gotten good. All right. The second question for today. Anybody know the name of this guy? He's quite often called the grandfather of AI. There you go, Alan Turing. There you go. So who was that? That was Alexander Trinkies. Okay, Alexander, you got that one correct. Alan Turing. Anybody seen the movie, what was it called? The Imitation Game? And that was really Alan Turing sort of developing his theories on the computer, for one. Maybe not the inventor of the computer, but he certainly took the computer to new heights and had a vision for the computer that was way ahead of its time. But he's really the grandfather of machine learning. So that was really what Alan Turing was all about, was trying to take the computer and using it to predict the answer given certain input. And at the end of the day, that's really what machine learning is all about. His theory, a lot of his theory is based on another gentleman by the name of Thomas Bayes. Now, a lot of people have not heard of Thomas Bayes, but yet anybody in IT security that's ever used email, maybe 20 years ago, I'm kind of dating myself here, would have used Thomas Bayes' theories. So if you've ever heard of Bayesian logic, that was kind of the way that we used to do email or spam protection in the old days. That was really based on theories from a guy named Thomas Bayes. And was basically where you would feed good data and bad data and essentially train the system on how to reason probabilistically on the outcome of something based on input that you were feeding into the system. Again, an early precursor to machine learning. And so Alan Turing's got a very famous quote where he says, "What we want is a machine that can learn from experience." And again, this is what machine learning is all about. The ability to predict the outcome of something based on input. Okay, third and last question. Anybody know who this character is? Nobody ever take political science? This guy's probably the most famous name here. Now, a couple of guys are saying they can't see the slides, but I see a few answers from people. So can somebody just confirm for me that they can see the slides? Okay, you guys can see them. Yeah, Karl Marx. All right, now Karl Marx might be a funny guy to mention in this presentation. A lot of people think of Karl Marx as the inventor of things such as communism, Marxism, more of a political science kind of guy. But really, Karl Marx, in my opinion, more than anything, was really a futurist. And that's really what he was responding to. So Karl Marx grew up in the dawn of the Industrial Revolution. And you know, I won't go into a tirade on what that was all about. But essentially what Karl Marx was looking at was making predictions about the future and how that was affecting labor, the workforce. And so 160 years ago or thereabouts, at a time when the light bulb hadn't even been invented yet, Karl Marx had made a couple of startling predictions, especially when you look at it in today's light. So he predicted that robots, and that was the word that was used, would replace humans in the workforce. Now, this is translated from German, and it's a bit of a mouthful, but just bear with me. Once adopted into the production process of capital, the means of labor passes through different metamorphoses, whose culmination is the machine, or rather an automatic system of machinery. The workers themselves are cast merely as its conscious linkages. He's predicting automation. He's basically saying that people won't do the actual work in the future. People will just push a button and the machine will do the work. So Karl Marx was really talking about automation, and he saw this hundreds of years ago, way before his time. Right, 1858 is when that quote was actually built. All right, let's take a fast forward to today's environment. All right, so those three guys that had answered, I'll make sure to get in touch with you. In fact, here, let me just type in my email. And just send me a quick message and I'll get in touch with you on how to get you your prize. Okay, back to the presentation. All right, so today's threat landscape. What does today look like? Let's fast forward a couple hundred years. Skill shortage, right? So this is this is something that's well known. A lot of different stats flying out there today, but finding good IT people in cybersecurity is tough. They predict there's about a 3 million IT security job shortfall. 3 million jobs that go unfulfilled just because there's too few people with the skills for cybersecurity. Advanced threats, of course, those continue to grow, and we see that in the news every day. In fact, we saw that a couple of days ago with that whole Colonial Pipeline mess. I won't go into those details today, but advanced threats continue to grow. Should be no surprise to anyone. The other big one, though, is information overload, and this is very relevant to today's conversation. The average human can only digest and do so much. They say an average analyst can do anywhere from 20 to 50 alerts a day. But the average SOC is probably seeing upwards of 10,000 events per day. So how do you sift through all that? If you don't have enough people in the workforce, in the SOC, I should say, how are you going to triage upwards of thousands of events per day when a human analyst can only do 20 to 50, right? So information overload is becoming a major problem. Time to detect and respond. Now, there's a couple different stats you can use to hammer this one home, but one from a couple of years ago done by, I think it was Verizon in their data breach report that they put out every year. They had put out a number of, an average enterprise takes an average of 197 days before a breach is discovered and takes them almost 70 days to contain it. That's a long time for somebody to be sitting around in your network exfiltrating data. So obviously something's got to change to make that better. A couple more points. Another issue for the analyst. The average enterprise has almost 30 different security tools in their network. 30 different vendors running around trying to fix various point product problems in your network. That's 30 different vendors where you need training, 30 different consoles that need to be looked at when all hands on deck trying to contain a breach. That makes things difficult for the analyst. Increased threat vectors, we talked about that, but really what this point's trying to hammer home is threats that are in areas that we traditionally haven't had to worry too much about. So as we move data to the cloud, whether that's infrastructure as a service or putting things, software as a service, we need to now worry about threat vectors in those spaces. How do we gain visibility into those areas? And so that's another new growing concern each and every day. Environment complexity, we talked about that. And then financial cost. So this stat I took from our EDR folks and some research that they had put up there was it takes 16 days on average to remediate ransomware, right? So think of a Colonial pipeline, for example. That's a ransomware attack. It'd be interesting to see how long it takes them and whether they fit this mold. But 16 days is the average that it takes your average enterprise to recover from a ransomware event. Now, the actual and generally what happens during a ransomware event is everything gets shut off, everything gets shut down as you try to remediate and clean. And so it's not so much the cost of the ransom. It's not even so much the cost of the tools that you now need to invest in. It's how much does that 16 days of downtime where you now can't deliver gas, how much does that cost? And so that'll be interesting to see what that financial number from Colonial ends up being. But on average, it could be 10 times the actual ransomware event. I think we'll see with Colonial that that 10 times is maybe more like 100 times or 1,000 times. All right, truth about IT security. So let's be honest. As much as I like to tell you that I can protect your network with the right tools about ever getting malware or ever being breached, that probably isn't true. Any vendor that tells you that you will be 100% protected at all times and will never be breached is either a sales guy or is just plain out lying to you. You will get breached at one point. You will be penetrated. Your network will be penetrated one way or another at some point. And what today's discussion is really about is not how do we get you 100% protection, because I don't know if that's truly possible. In fact, Gartner even says it too. Gartner's got a famous quote where they say, hey, breaches and attacks are inevitable. You will get breached at one point. So today's discussion is more about what do we do when you do get breached, right? So if getting you to 100% is not possible, what do we do then to enhance detection and response capabilities for when it isn't? And that's really what the SOC, today's SOC is really all about. This is what separates the men from the boys, the women from the girls. It's your ability to respond to a breach, to an attack. That's what really makes the difference in today's modern SOC. So let's talk about some building blocks of a modern day SOC. First building block that I think any modern SOC needs to consider is the collection of data. So data is the lifeblood of a SOC. You can never have too much data. The only person that's ever going to complain that you're collecting too much data is your storage guy. But from a security analyst point of view, there is no such thing as too much data. You cannot collect enough data. And collecting data from a very wide breadth of sources is key. So from collecting data from the network, from your endpoint, of course, from your firewalls and security devices, that's a no-brainer. But collecting them from identity stores, this is crucial to the SOC, because we're going to throw some tools at this that are going to look at all of this log data and try to correlate an event, trying to figure out exactly how you were breached. And to do that, we need to collect data from everything that has been possibly involved in that breach. And so detection, and that's really what I'm trying to talk about here when I sort of made that last statement from collection. So the goal of collecting all this data is to really allow us to detect a breach in all of its various guises and all of its various steps, so that we can look at how your network was penetrated in the first place, what was stolen, was there credential theft, all of these sort of things that we want to do at the detection phase and the investigation phase, only possible through collection, right? So, again, I keep coming back to the collection of data, and this is key. So after you've detected that breach, it's all about investigation, okay? And this is what any modern SOC that's worth its salt is really going to be focused on at this point, is investigation. Now that you've collected data, you've detected a breach, now we get into the investigation stage. And this is where we're looking under the hood, looking throughout the network. Hopefully we've collected enough data from enough different sources that in the investigation stage, we can start to piece together on how a piece of malware got into the network, how data was exactly exfiltrated. And that's going to be important for step 4. So step 4, in terms of building blocks for the modern SOC, is all about recommendations. A couple of other different ways to describe this stage. We could talk about it in terms of prediction. We can talk about it in terms of action. But this is, now that you're armed and powered with, the detection of something that went wrong in your network. We've got the tools at the investigation stage to know how it was executed and what it's infected. The recommendation stage is all about taking playbooks or a process where we then go and remediate this event, and putting things back to the way they were, and then executing something to stop that attacker from getting back into the network. Now, this comes in a lot of different guises, this stage. It could be threat hunting, it could be best practices, it could be auditing, could even talk about risk and compliance scoring, and then something that's a bit more modern is prediction. So something we can also do in the modern SOC is predict whether an attack has occurred, even though a particular black and white alert hasn't been received. But maybe we're seeing behavior that is indicating something abnormal, or behavior that's indicating there's going to be a problem if things continue. So prediction or predictability. We talked about it earlier with machine learning and our friend Alan Turing there, but that's another big piece to step number 4 that's going to become more and more prevalent in today's SOC. The 5th tool is about orchestration. So I kind of talked about that already in step 4, but after we've got our recommendations on how to get things back on track, orchestration is really the execution of that recommendation. And so these will be things such as playbooks, remediation scripts, whether that's restoring things from backup, which is kind of the brute force way of fixing things, whether that's going into the registry of various endpoints and deleting certain IOCs, putting up various IP addresses on a quarantine list. The list goes on, of course, but that's what orchestration is all about. And we talked about Karl Marx earlier and why he was so important. And again, he was talking about automation, and that's step number 6 in this building block of the modern day SOC. All automation is really orchestration in its most pure form. And reason why automation is becoming so important is I talked about shortage of analysts, talked about how the analyst is faced with too many tools, too many alerts, too many events for them to kind of sift through. And so that's why automation is now becoming important, because the only way to scale is if we start letting the machine take over to some degree. Now, automation can be done in a bunch of different guises. It doesn't necessarily mean letting everything up to the computer. Certain pieces can be automated that you're comfortable with. Maybe call it semi-automation. But we need to start leveraging tools in the SOC. If we want to protect our network at the speed of the attacker, we need to start leveraging automation in our orchestration, so that the alert that we're getting isn't that you've been breached and that someone just stole 10 gigs of data from your database, but that the alert we're getting is, hey, we just blocked an attacker on the firewall. They tried to steal some data. That is an alert that would be better than the one I just mentioned earlier, and that can only be possible if we start letting automation take its role. And then collaboration. So you heard the famous line from Hillary Clinton that it takes a village to raise a child. Well, I say it takes a village to stop a breach. And what I mean by that is, if you've ever been breached, you've ever been part of an investigation in a large enough network, it's an all hands on deck team effort, right? You're pulling people from the server, applications, network security. It's all hands on deck. It's people from all sorts of places that are coming together to try and put together what's happened. Everyone coming with their own unique viewpoint of the network. And so collaboration and being able to share data, being able to share the playbook, being able to share the process, the evidence in a common repository. That's another very important piece to that whole investigation and remediation story of the modern SOC. So collaboration. And last but not least is reporting, right? This should be a no-brainer, but reporting can come in a couple of different ways. One of the important metrics of trying to figure out whether your SOC is working or not is being able to report on metrics, on how fast you've been able to recoup from a breach. And so that's why reporting becomes important. And reporting we kind of talked about earlier in stage 4, step 4. Let's just go back to that real quick on the recommendation phase, right? So this is another part where reporting becomes very important in basically being able to look at data and audit whether you're fitting the mold of a certain compliance environment, or whether you're getting more alerts this week than last week. It kind of gives you sort of a baseline on how to measure your security practice. Okay. All right, let's talk about SIM. Right, SIM should be the foundational building block to any SIM. This is really a tool for visibility, and you really can't fight what you don't see. That's really the story here with SIM. So I'm just going to throw a couple of screenshots here on a solution from Fortinet called FortiSIM, and just talk about some of the value here in where FortiSIM fits into the NOC. So again, all about visibility. This first screen that I'm showing here, just a snapshot from the FortiSIM GUI, and this is really talking about how important it is to take stock of your assets. And so that's really where our starting point is with FortiSIM, is doing a discovery and a categorization of all of the assets and inventory on your network. And that's really from a visibility point of view. And this is done in an automated fashion where we can basically suck in all the devices on your network into the tool, so that we can tell you where all of your devices are, what your devices are. Also helps with IoT and BYOD, and being able to detect devices on the network that maybe you didn't know you had. I should say, not only are we detecting devices, but we're also detecting applications and users. And we can use this information as we pull in data from other sources. We can even get so good as to tell you what user is on what device, with what MAC address, with what IP address, on what switch port, on what switch. And so that becomes very valuable when it comes time to remediation, because we know exactly who you are, where you are, what you are, and if something's going on that machine, makes it very easy for us to pinpoint exactly where that problem is, and who needs to potentially be isolated. State monitoring. So this is just going into a few more sort of details on relating to asset discovery, where we can also look at the configuration of potential devices that we've brought into the CMDB. So we can also keep track of who's making what configuration changes and what configuration changes have they made. So if somebody's gone into, maybe somebody's hacked into a switch or a router, or your firewall, God forbid, maybe there's changes that are being made. We can see exactly who made that change, from where, and what change did they make. Now, of course, any SIM that's worth its salt is going to be third-party agnostic, and that's really what I'm trying to do with this slide here, is just show all of the different vendors that FortiSIM can work with. And there's like some 400 odd different vendors that can be brought into the solution, and that can be integrated into FortiSIM, and that's going to be important for any SIM solution. Something else that we do on FortiSIM, it's a little bit unique, but still very important, and again gets back to some of that machine learning I was talking about earlier, and the ability to predict things. User behavioral analysis goes hand in hand with this, but FortiSIM likes to collect performance statistics, not just security or quote unquote traditional security metrics. So what I mean by that is we like to know the CPU utilization, memory utilization, disk storage utilization, just to name a couple of metrics, but network interface utilization. These are things that are sometimes more NOC oriented, more network operations centric, but we like to take in this data as a way to detect threats that are occurring more on the physical layer. So think of a DOS attack, or things that are going to lead to a process being hijacked, things like that. These are going to manifest itself at the physical or performance layer, and so we like to collect this sort of statistics in FortiSIM as a way for us to predict whether there's something going on that otherwise is going to seem not so obvious. Risk monitoring. So one of the things that FortiSIM will do is, as it's collecting all of these alerts, as it's using its user behavioral analytics engine, it's basically able to profile devices on the network from a risk perspective. So if there's certain servers that are being targeted more than others, if there's certain users that are exhibiting malware events or other type of security events more than others, these are going to accumulate a risk score that's going to bubble to the top. So it's basically going to help you as the operator see your problem child or children and give you a place to start. One of the things of a SIM is you'll never get through everything that a SIM is going to complain about. But one of the things a SIM can do to make your life better is at least tell you which things need to be fixed first. And that's really what we're talking about here with risk monitoring. Let's go to the next slide. Now, integrating with third-party intelligence sources is also very important to things such as SIM. And so as we sort of bring in alerts and events from devices and the network and applications and whatever else we're collecting data on, one of the things we need to do is correlate that data with threat intelligence sources, whether it's Fortinet's own threat intelligence lab, whether it's a third party like Anomaly, VirusTotal, other players in the intelligence game, but being able to take IOCs from third parties and measure those against data that we're bringing in, that's important in helping correlate whether there's truly risky behavior that we're detecting. And so that kind of helps sort of validate whether the SIM, as it's correlating with its own threat intelligence, no one has the entire source of the truth. So the more the more sources we can bring in to validate something, the better. So I talked a little bit about UBA, and we talked about this when we talked about machine learning earlier in the conversation. And so UBA is really, or UEBA, depending on whether you're more endpoint focused. But this is really all about detecting an event that is occurring on the network, not so much based on a blacklist or a particular single detection of an event, but it's more the collection of how something is behaving that ends up leading itself towards whether we think something malicious is going on. So for example, if we see somebody who's logged in to the network from Kiev, Ukraine today, but this user has never logged in from outside of the state of New York, that could be an example of where the UBA engine starts to go, hey, something's fishy here. I see somebody logging in from somewhere they've never logged in before. Or someone's accessing an application or consuming 10 times the data that they've consumed before. So things like that is really what behavioral analytics is all about. And again, that comes from that step one that I talked about earlier in collecting information from all sorts of different places where correlation can then have a very wide breadth of things that it can use in its footprinting of whether it's seeing an event that just doesn't make sense. Okay, I'm going to skip a few slides in the interest of time. We talk about investigation being really important. We're going to talk about this a bit more when we talk about SOAR in a second, but investigation, maybe one of the most important parts of a SIM or any SOC is the ability to take that data and then drill down into it to see exactly how did this breach manifest itself. When did we first start to see various indicators or traces of the origins of this attack? And so we've also integrated the investigation dashboard and reports with the MITRE framework. And so, MITRE's done a lot of work over the years and try to help the analysts understand, how does this particular event map into, the building block of an attacker's sequence of events as they've breached your network. And so you'll see a lot of that built into the FortiSIM tool from an investigation perspective. In fact, here you see the SIM MITRE dashboard in all of its various flavors, sort of taking various events and putting them into their various containers that MITRE has defined from an attacker's point of view. All right, let's fast forward through these slides. Now, response. So I talked about this as well in how this is, again, something that the modern SOC is very much, very much front and center of today's modern SOC. And it's that ability to respond to an event, whether it's malware that's in the network, whether it's a breach, whether it's someone who's trying to attack a server and gain a foothold. We'll talk more about this as we talk about FortiSOAR in our next section here. Now, from the FortiSIM perspective, though, as we talk about response, this is also about integration. And so, any SIM that's worth its salt is going to be able to connect with third-party things from an API perspective, such as ServiceNow, ConnectWise, and this is going to help us in a couple of different areas. If you're a large enough enterprise, you're probably going to be using those tools for your ticketing. And those ticket systems are not just built for IT security, but they're going to be built for help desk. They're going to be built for the whole IT infrastructure and network as a whole. And so the ability for the security guys to join that and work with that system is going to be important. So ServiceNow and ConnectWise with FortiSIM, we can connect, and we can also connect not just from opening tickets. But remember earlier, I talked about that whole asset discovery, visibility perspective. We can also work with ServiceNow, for example, in a bi-directional point of view in sharing CMDB data. Devices that are on the network. Do they belong on the network? Have they been sanctioned by IT to be on the network? All right, so let's just skip that slide. Let's go to 40 SOAR. So really what I want to talk about now is next-gen orchestration and automation. In my mind, if we're really going to talk about the next generation SOC, it's really about SOAR. SOAR is really what's going to define your ability to truly remediate and recover from an event. And so let's talk about how SOAR does that. So SOAR stands for security, orchestration, automation, and response, right? So it's basically a tool that helps automate and orchestrate the remediation of security events. And we'll talk about that in a bit more detail. But some of the things we're trying to solve from the SOAR perspective, reducing time to respond, that's the big one, right? Talked about that when we talked about automation. So again, a lot of things can be automated in SOAR, and that's really where we're trying to get people to ultimately, but it doesn't have to be, right? SOAR could be a manual process that you're executing, or it can be done in an automated fashion. But really the idea here is to reduce the time it takes for you to fix the network from a security perspective. And that's, leveraging, or not leveraging, but that's also addressing the whole analyst skills gap. So rather than having, trying to get all hands on deck from across the network, if you've got predefined processes that are turned into playbooks, and these playbooks are automated, that helps reduce the workforce that's needed to be pulled into the whole event. It's about reducing alert fatigue. So this is centered around the idea of, we have events that are coming into the SOAR. As we automate some of the investigation that goes into it, such as correlating with virus total, with third-party threat detection capabilities, or intelligence, we're not being forced to look ourselves into a whole bunch of manual processes to determine whether an alert is truly significant or not. Right. So really, this is about trying to take those 10,000 different alerts that you're going to get throughout the day and bring them back into that 15 to 50 sort of range where the human analyst would need to be involved in. So it's trying to take a lot of the mundane stuff and take it off the table and just leave the truly complex things to the analyst to worry about, and reducing human error. So if you've taken a process and built it into an automated script that works each and every time, and maybe even automated it, that's reducing human error. If it's easily repeatable, then letting the machine do it with maybe the execution of pushing a button or in an automated fashion, that again reduces the ability of the human to screw it up. All right, so the business driver here in the unified response management, that's really business driver number one of 40 SOAR, right? It's the ability to orchestrate, automate, and respond to an event. Number two is that alert triage, the ability to investigate through a streamlined process that's hopefully automated, so that again, we're leaving only the complex, only the cream of the crop, sort of the top maybe 15 to 50 incidents, and the rest of them can essentially be dealt with at a lower level or in an automated fashion. But trying to leave alert triage to the point where it's manageable. And then collaboration. So 40 SOAR is also all about creating a collaboration environment where evidence can be collected, forensics details can be shared, and creating essentially a platform that everyone can log into to view this data, to view these IOCs, share their own data that they may have from their perspective, and that sort of thing. So you'll see a whole collaboration initiative capability behind SOAR tools today. Now, how we get SOAR integrated is quite simple. And SOAR, like SIM, is going to be very third-party agnostic. Any SOAR that's worth its grain of salt just like a SIM, is going to have to work with third-party devices. And you're either going to see various parsers that are being supported, or connectors and APIs that'll connect with various log sources or other devices that we need to work with from a remediation perspective, as well as intelligence and various lookup tools, right? So when we want to do lookups for IP addresses and domain names, whether if we want to correlate with threat intelligence sources, those are going to be connectors you're going to be using on the SOAR side to connect with those devices. And so it's all about taking in data from your SIM or even from devices directly. You don't even necessarily have to take it in from the SIM, although that's usually the best place to do it. And then working with your best practices, where you take those best practices, such as how to deal with a malware event, how do we recuperate from a breach or data exfiltration. You take these sort of high-level best practices and you create playbooks out of those, so that when you do get breached, when you do see malware, there's either a button you're pushing or it's automated, where a playbook kicks into action, where various processes from a security and IT perspective are going to be are essentially going to execute in isolating devices, doing triage lookups, that sort of thing. So at the end of the day, it's all about case management, creating a repository for evidence, consolidating the whole investigation and response side of the SOC. It's about sharing knowledge through the collaboration tools that are available in the SOAR, and then also another data point for reporting on metrics. Here's a quick dashboard of FortiSOAR. Again, just showing you a quick overview on, from a high-level point of view, different types of alerts that have come into the system. Then you can, of course, drill into. So we see brute force attempt, malware event, phishing event, policy violation attempt. Then on the left, we can see the criticality level of those events. And so it just gives you a data point on where to go looking for various types of alerts that you may want to go triage or investigate. This is just showing an alert with some details on the right. So this shows a playbook that's being executed for a brute force alert. It's showing where the original attack was sourced from. It's showing where the destination of the attack, so your internal server. There's a couple of other playbooks, as you can see, that have been executed. So there's a playbook that's telling you where this IP is from. It says, hey, we did a lookup with VirusTotal. VirusTotal doesn't like this dude and has seen this actor and classified it as malicious. So again, just talking about how we can run playbooks with third-party intelligence sources to kind of gain a better idea on intelligence. And then it's basically saying that our Splunk has told us that the same IP address has been used in other nefarious activity throughout the time that we've been collecting data. So again, just kind of a quick, easy, dirty look on how we can take an alert, and because of all these automated playbooks in the background that are doing various triage and investigation sort of scenarios, we can bring in a whole bunch of data that maybe this would have been a manual process before to look up all of these various things. But instead, when I look up this alert, it's already done for me. So I can tell right now that this alert has been confirmed by VirusTotal. It's been confirmed by my SIM, and this IP has been doing other things as well. And then finally, I got a playbook that's basically telling me that this is indeed a brute force login attempt. And if I had automated the response to this, there would have been another playbook that basically would have said, we've isolated this external IP address on a blacklist on our firewalls. We maybe even could have taken the server offline if we thought that was something in our playbook that needed to be part of the action. This just shows the playbook I keep talking about. So this is a visual playbook on how you sort of build the various building blocks that go into these processes. So this is the virus total piece that I just showed you in that alert. This is how you could build. In fact, this one's already built for you out of the box, but just showing you how the virus total one would work. If you want to use a playbook to automate the threat intelligence correlation with virus total, or pretty much anybody else, this is what that looks like. Very easy. It's very drag and drop. You can also write code if you want to do it that way too. I talked about third party, agnostic being important for SOAR, just like it is with SIM. And again, that's what this slide is all about here. All right, let me close things off with the third product solution, really, that's very important to today's SOC. And that's going to be EDR or XDR, as we're now sometimes calling the next generation of EDR. So EDR, endpoint detection and response, that's really the big word there, and what differentiates EDR from just endpoint protection. It's that whole response capability. And again, I keep harping about response throughout this presentation today. Today's SOC is really all about forensics and response. That's what separates today's modern SOC from the SOC of yesterday. It's that ability to, how do we respond from a breach faster than we typically have before? And EDR or XDR has got a big part to play here. And so, one of the big things about EDR from an EPP perspective, but also lends itself to, forensics, but, EDR tools today are not really very reliant on blacklisting technology. What we do with FortiEDR is the way that we detect a malware event or a breach or any sort of attack is based a lot less on blacklisting and a lot more on user behavioral analytics. So EDR is all about detecting an attack based on what the agent is seeing, what behaviors the agent is seeing being attempted on the endpoint. So we're not beholden to any sort of blacklisting threat intelligence source to tell us whether there's malware. We can see it by how a particular process or file is trying to interact with the system. And so that's very game changing, especially based on older generation of AV detection solutions. But the real story I'm trying to get at here today is really about the prevention side and the response side of the EDR tool. And so I'm going to skip this slide, but what we're looking at here on this dashboard with FortiEDR is the ability to see some of your details on what you would see with a malware event. And so what we see here is a particular executable. We can see IP addresses. We can see where this file is located on the endpoint. We can see the verdict that EDR has given it. We can see the processes that are being opened and being created. And then not only can we see from a behavioral point of view if FortiEDR likes it or not, we can also see from, I'll be on the next slide, but we're also seeing from FortiEDR's perspective, it will also do lookup to things like a sandbox, the virus total, going to the SOAR and SIM, and seeing if there's other correlation activity that's occurring with that hash or that IP address. This is a screenshot showing the communication on that endpoint. So something else that we can do with FortiEDR is as applications are communicating with the outside world, we can look at the vulnerability stage or status of these processes. So if we see somebody using Mozilla, for example, or Firefox, I guess really, and we're seeing maybe a deprecated version or an old version that's got severe vulnerabilities, we can detect that at the EDR stage. And we can even have policies built to shut those down so that highly vulnerable activity won't be allowed to communicate. So that's a bit of a game changer. This here is that screen I was just showing or trying to talk about earlier about being able to correlate a malware event with other third parties in terms of correlating with VirusTotal, being able to use other threat intelligence to correlate whether a malware event is occurring. Now, I'm going to run out of time here, so let me just sort of close off with maybe 2 more slides. So the whole idea, though, behind EDR versus your traditional EPP solution is really built around the ability to remediate, and that's what this screen is showing here. Is not just we don't just have to be harsh in terms of throwing somebody off the network when we see someone having downloaded malware. Some of our remediation can be terminating processes, removing things from the system, such as deleting the file, deleting registry entries that have been put in there that shouldn't, as well as isolating that endpoint right from the network. So there's a lot of different things we can do when we talk about remediation. It's not just about isolating the device off the network all the time. And that's especially important when we're talking about servers that maybe we don't want to put offline. There's other things we can do besides just isolating them off the network. So I think that's an important part of the story. So let me just close off here then with a summary slide, and then I'll kind of go through some questions here. So the whole idea behind today's modern SOC and the ideas behind automation and response capabilities is really about bringing efficiency to the SOC. So as I kind of showed earlier, your typical human analyst just isn't going to be able to handle the volume that they get today. And so SOAR and SIM and today's modern SOC is all about bringing efficiency back to the network, either through automation or pre-scripted processes that are built into playbooks. And so really, guys, that's what I really wanted to bring to the forefront today in my presentation was just how today's modern SOC is trying to bring efficiency back through things such as automation and machine learning and integration. So with that, I just want to thank you for your time today. I don't know if I'm going to be able to get to some of the questions. I think we're going to have to close off, but I do see some in the chat window. So let me maybe respond to those as well as those winners from the first from those first 3 slides that we went through earlier today. And thanks, guys. Take care and enjoy the rest of the show.